Hello everybody, so today we're going to learn about trigonometry. What is trigonometry about? Trigonometry is all about triangles. Trigonometry helps us to find angles and distance, and it is used a lot in science, engineering, video games, and more. So, right angle triangle. The basic part of trigonometry, the basic component, the introduction to trigonometry we're going to do is the right angle triangle. This in the video, in here, is the right angle triangle. Right angled. The right angle triangle is of most interest for now. So the right angle triangle is called the right angle triangle because it has a 90-degree here. 90-degree here. So you're looking at this right angle triangle and you're probably wondering, what is this symbol here? This is called theta. Theta is basically a Greek symbol that basically denotes an angle. So we use theta to denote an angle. I'm going to write it here. So theta is equal to angle. So we use theta to denote an angle. So let's first label our right angle triangle. Let's label and let's see how we can use this triangle from trigonometry. So this side here is called the hypotenuse. The hypotenuse is our basic. So the hypotenuse is the long side of the right triangle. This is called the opposite. The opposite is, in its name, the opposite to the theta. And this is called the adjacent, which is the bottom part of our triangle. So the hypotenuse, the adjacent, and the opposite. We have to know these off by heart. So let's figure out what trigonometry is all about. So the main functions in trigonometry is sine. So our main ones are sine, cosine, and tangent. So these are our basic trigonometry functions. So sine, cos, and tan. So what is sine, cos, and tan? Let's figure out what cos, sine, and tan is. Sine, cos, tan. So our sine theta, if we look over back here, we can see that we've got the opposite, adjacent, and hypotenuse. I'm going to copy this here for us to have here. So our Our main parts of the triangle are detailed below. So we've got the hypotenuse, the adjacent, the opposite. So let's try and find the sine, cosine, and tangent using our hypotenuse, opposite, and adjacent, the labeled right angle triangle. So our main part is going to be our main functions are going to be sine theta, which is equal to opposite over hypotenuse. You've got our cos theta, which is our adjacent over our hypotenuse. And we've got our tan theta, which is our opposite over our adjacent. So we use these functions to work out the angle, the distance, the sides of the triangle, because many parts, and we'll see by the example here, that many parts will have to use this sine, cos, and tan. So let's think how we can use this, how we can memorize this. So we have a simple mnemonic to memorize what our values are. So sa, ka, toa, our sine, our cos, our tan. So SOHCAHTOA is sine, opposite over hypotenuse, cos, adjacent over hypotenuse, and our tan, which is opposite over adjacent. So sine, cos, and tan, so SOHCAHTOA. So as we can see here, we've got our hypotenuse, opposite, and adjacent, and we can use them to find and derive the main functions in trigonometry. So let's take an example here. Our question here is, what is the height of the tree? So what is the height of the tree? The tree. So what is the height of a tree? We have to use trigonometry to find this. So let's try and find the height of the tree. So we've got our hypotenuse here. Let's label first our right triangle. So we've got a right angle here. We've got our hypotenuse there. I'll do another color. Our hypotenuse here, you've got our adjacent here, and you've got our opposite here. So what we're trying to find is our opposite. So we need to think, what equations use our opposite? So sine uses opposite over hypotenuse. Sine is equal to opposite over hypotenuse. You've got a cos, which is ka, our adjacent over hypotenuse, and you've got our tan, which is OA, so O over A, opposite over adjacent. So we can take out some of them. So we can take this. We can take our cos, because we don't have an adjacent to find, and we only have our hypotenuse and our angle. So we need to find an equation that uses the hypotenuse and opposite. So which one do you think that is? It's the sine. So the sine, let's write our sine equation here. Sine theta is equal to op over hypotenuse, so opposite over hypotenuse. So let's try and plug in the values that we have here to see if we can find our opposite. Our opposite here. So we've got sine 45 because of the angle, so theta is our angle, is equal to opposite, which we're trying to find, over hypotenuse, which is 20 meters. So to find our height of the tree, we just have to times 20 by sine 45. So opposite is going to equal to sine 45 times 20. So sine 45 is equal to 0.7071 times 20 will give us our opposite. When you're using angles, most of these angles we have to really use kind of rounding. You don't want to type in the really long answer calculator because we just need to do it to 4 significant figures. 3 decimal places is fine. Just do it to 3 decimal places and you'll be perfectly fine. So sine 45 times 20 will give us our opposite. So 0.7071 times 20 gives us 14.14 to 2 dp. So our height of the tree is 14.14 meters to 2 decimal places. So you can do any decimal places. Just be careful in some of the questions, they will specifically ask you to what decimal place they want you to. So basically just figure out the equation that you need to use and times and divide, and then you can get it. Thank you very much, and thank you for listening.